Hello and welcome to problem 5 in my Calculus 3 or Multivariable Calculus problem solving series. In this video, we're going to find the arc length of a function in 3D. Let's go ahead and look at how to do that. So, we're going to look at how to find the arc length of a function in 3 dimensions. So, the idea behind arc length is that you have this curve in 3 dimensions, and you want to find the length from A to B. To do this, we're going to divide the curve into very small pieces, and what happens is that as you divide the curve into smaller and smaller pieces, they become straighter and straighter, and when you divide it into infinitely small pieces, they become into a straight line, a little line segment. And we're going to add up all of those line segments, the length of those line segments, and this will give us the length of the curve. To get the length of the line segment, we need to take the derivative of the function r, which is the curve in 3D. So let's go ahead and take a look at the formula. So here we have the formula for the length of the curve, and this is going to be the integral from A to B of the magnitude of r prime. So the derivative of r, and you take the magnitude, and you take the integral from A to B. But you can also write this as a function of another parameter. So here we have an arc length function. So it's going to be from A, a constant, to U, which this time it's a variable. So it will be from A to U of the same magnitude of r prime of t, dt. Another important thing to note is that if r is the position of an object in 3 dimensions, then the derivative of r will be the velocity of that object. And the derivative of the velocity, or the second derivative of r, will be the acceleration of the object. So in the integral, when we say that we're taking the magnitude of r prime, if r is the position of an object, then r prime would be the velocity. So we're actually taking the magnitude of the velocity in the integral. So this question asks us to find the length of the curve r of t from t equals 0 to t equals 1. And the r of t, the function, is t cubed, comma 3t squared, comma 6t. And I've drawn a picture here for you to see, and it's this curve here, and they want us to find the length from t equals 0 to t equals 1. When t equals 0, r of 0 is 0, 0, 0, and when t equals 1, the point is 1, 3, 6. So it's from this point to this point, and we want to find the length of this curve. So remember that what we're actually doing is we're dividing this curve into small little pieces, and when we divide it into infinitely small pieces, these little pieces become line segments, and we can find the length of the line segment using Pythagorean theorem, or the derivative of r. So looking back on our formula, the first step we need to do is to find the derivative of r prime of t. So the derivative of r prime of t, we're just going to take the derivative of each of its components. So the derivative of t cubed is 3t squared. The derivative of 3t squared is 6t. And the derivative of 6t is just 6. So now this is going to be r prime of t. The next step, we need to take the magnitude of r prime of t. So the magnitude of r prime of t will be the square root of all of its components squared added up. So we see that we get the square root of 9t to the power 4 plus 36t squared plus 36. And with a little bit of factoring, we get the square root of 3t squared plus 6 squared. So we find that r prime, the magnitude of r prime, is equal to 3t squared plus 6. Now we have to take the integral of that from 0 to 1. And this will give us the length. And the integral of 3t squared plus 6 is going to be t cubed plus 6t. And we're evaluating it from 0 to 1. And we see that the length is going to be equal to 7. So hopefully this video helped you understand how to find the arc length of a curve in 3 dimensions. If you enjoyed this video, then make sure to like and subscribe, and also comment down below what video I should do next. Thanks for watching.